Number 7 on this one, we are given a story. So I'm not given a graph. I'm not going to worry about this. So given a story, sketch a graph. Okay. Explain the y-intercept, rate of change, increasing and decreasing. The science class launched a model rocket. It flew to a peak height, and then its parachute opened and drifted to the ground. So we need to make a graph. Okay. And we're graphing time and height. Height should be over on the left because the height changes over time. So height and our time. At the very beginning of this story, our rocket is on the ground. At 0, our rocket is on the ground with 0 height. Okay, so it'll be right here at 0. Then, right off the bat, in a short amount of time, we should notice that our rocket's height increases very quickly. And as it gets higher and higher and higher and higher and higher and higher, it's going to slow down. It's going to slow down, slow down, slow down until it gets to a peak height. Okay, so this is the peak. This is the highest point at which this rocket's flying. And then a parachute opens and it drifts to the ground. So instead of it just falling straight to the ground really quickly, it's kind of going to drift down at a constant speed all the way to 0. And it looks like I need to kind of redo this graph. So I'm going to redo it down here because I definitely ran out of room. So I'm going to say maybe here's my peak and here's my drifting to the ground. Okay. And then there's my peak. All right, so ignore this one for a sec because I think I just ran out of room. Height, and this is my time. So my initial, my y-intercept, that's my initial value. So my y-intercept, that's at 0 because it starts on the ground. The rate of change, it starts going really high really fast, and then it slows down. And then it falls to the ground slowly. So at the start, height increases fast. And then once it gets to the peak, so how about after the peak, it slowly reduces back to the ground, back to 0. Increasing and decreasing, we actually covered both of those in our rate of change. So graph should look like this. It shouldn't look like a straight line at the beginning because when you throw something in the air, you should notice that it slows down until it gets to a very top point, and it actually like almost stops in the middle of the air, and then it comes down and speeds up, speeds up, speeds up, speeds up. But in this case, we have a parachute, so it reduces, it declines, decreases back at a constant rate. All right, so how about at the very end of this? It slowly reduces back to the ground at a constant rate. All right. I think that last part's important because it does go at a constant speed straight down. It doesn't fall and accelerate like it did at the beginning.